Hello everybody, this is Stranger's Cat. Today we'll be doing Codeforces Global Round 19. 40 seconds for the contest. And I don't have anything else to speak today. Whatever, okay. If you're here for the solutions, you can go to the last part. But okay. Be with me till the end to see whether the cat survives or the cat dies, whatever. This is what I had planned for the intro of my channel, but half of the time I've missed saying that. But I guess I'll speak that from now onwards. Whatever. If I increase my rating, that means the cat has survived. If the rating decreases, that means the cat is dead. Okay, whatever. Let's go on to problem A. You have an array of length and you can exactly once select an integer length between 1 and n minus 1 inclusively, and then sort the prefix. Okay, choose some elements from the start and then sort it, and then the suffix of the array of length independent. Okay, you have to independently sort it. For example, okay, you choose. Then could it be that after performing this operation the array will not be sorted? Okay. Yes, it is. Okay, so how will I check if I have something like this? I want it not to be sorted, right? So if I just choose this much and then this much, it won't be sorted. Yes, so how will it, when will it be sorted? If it is already sorted, right? Otherwise I don't think it is possible. Yes, you sorted A and N, right? Yeah. If it is already sorted, then no problem. If it is not sorted, then the first element is, then there is at least some element. Okay, also this, then there is at least some elements like 1 2 3 4 6 5. If I choose this much, yeah, I guess if I'm not missing anything, then this problem is very easy. And yes, what about the standings? Fine. Problem B. Let there be an array B. Let there be a partition of this array into multiple segments, fine. And for any I between 2 and C, what is C? Okay, holds that Ri minus 1 plus 1, fine, means it is consecutive segments, fine. Let's define the cost of the partition as max. C is the number of partitions we made plus the max of B Li. Okay, L1 Li plus 1 Ri for all where max is the smallest non occurring element. The cost of partition is the number of segments plus the sum of max of over all segments, fine. Max of this segment, okay, max of all segments, yeah. Let's define the value of an array bi b1 b2 bk as the maximum possible cost over. Let's define the value of the array. We have the whole array, the value of the array as the maximum possible cost over all partitions of this array. Okay, find the sum of values of all its subsegments. Okay, which is the maximum possible, right? Fine, we are at problem B. Yeah, let us also get some. Okay, yeah, we are recording some example test cases and its explanations also. Yes, so basically if we have like 1 and 2, so the answer for that is, I guess, 4. Okay, 4, because if I choose this as a whole array, we'll have 1. Max is the max of a set of numbers is the smallest non-negative number that does not occur in the set. Fine. Best partition is 2. One comma 2. How is the answer 4? Because if I separate it into different, maybe I can get 2 is the number of segments plus 0 as the max of this and plus 1 is the max of this. Not 1, it has 0 only, right? Find the sum of values of all its subsegments. Find the sum of values of all its subsegments. What does this mean? Sum of values of all its subsegments. Okay, let us the best partition of the subsegment 2 0 1 is 2 and 0 1. Okay, 2 plus 0 plus 2, that is 4. Yeah, it is 4. The best partition for the subsegment 2 comma 0. Best partition for the subsegment 2 0. Okay, for all the subsegments. Okay, if I have 2 0 1, one of them is like whole, so it is 1 plus 3, that is 4. I have 2 0. Okay, 2 and 0 1. Okay, the best partition for the subsegment 2 comma 0 is 2 and 0 separately. Okay, that is 2 plus 1, that is 3, right? Yeah, we have 4 1, then we have 3. The best partition for the subsegment 2 0 1, subsegments and not subsequences, right? It should be continuous subsegments, that means. Okay, that is fine. What is the constraints? Okay, and it's only till 100. Fine, n is till 100. So I can do it in n square also. Now if I have 0 1, fine, that means 2 0 1, right? Once I take only 2, so the answer is okay. So can I store? What is the most brute force method? Traverse in an n square method, like for each subsegment, finding the max of each subsegment. Can we do it in another? Can we do it in another? Yeah, like if n is 100, can we do finding the max in another order of n? So it will become 100 100 100 10 power 6, right? I guess it will work. So is it like directly brute force? Okay, we'll start from 0 and we'll go till n, and we'll have the loop of j. We'll start from I itself and we'll go till n. Fine, now we'll have to find the max. Numbers are themselves until 10 power 9, right? Okay, we can keep a map or something. Yeah, hash, and then we'll just loop from I to j. Okay, and we'll just do hash of ai of ak as 1. Now I have the hash, right? Now I will loop. I have max as equal to 0 while hash of max is equal to 1. While hash of max is 1, that means it is seen. I'll do max plus plus. Max plus plus. This means that if 0 is seen, max is 1. Like the first element which is not seen, that will become the max, right? And I'll do answer plus equals to max and just see out answer. Fine. Zero 7 9 20. That is totally wrong. I will go from 0 to n. That means n minus 1. See out I j and max. Okay, what's the error? Max. Okay. 0 0 0 0 1 0 1 1. While hash of max. Okay, answer plus equals to, I should also add the number of subsegments, right? Okay, wait, what am I doing actually here? For each subsegment, I have to find its best answer. Okay, if I have a subsegment like this, adding its max, we can divide it into many more subsegments. Fine. And how should we divide it into further more subsegments? If I have, like, let's suppose I have 201 only. So if I have a 0, it will give me 1. Okay, if I have a 0, it will give me one more. It will make my max not equal to 0, at least, right? It will make my max not equal to 0. Let's suppose I have 0 and 1. If I take it as a whole, my answer will become 1 plus. My answer will become 1 plus the max, which is 2. If I take it separately, my answer will become 2, and max of this is 0, and max of this is 1. So answer will become 3. But let's suppose I have this 0 0 0. So taking this will make my max as 1 plus number of subsegments as 1. So it will become 2. But if I take 0 separately, it will make my answer is 3 plus max is also 3, right? It will make my answer is 6. Okay. If I have 2 0 1 0 0 1 3, something like this, max is 4 in this whole array, right? Max of the whole array is 4. So I can either do 1 plus 4, or what I can do is, like, I can just separate it in separate numbers. If I separate it in different numbers, 1 2 3 4 5 6 7 7 plus, I may get a 10 1. Yeah, even if I, like, group, let's suppose I grouped, I have separate, and then I group these two to make the max greater. So my answer will become 1 2 3 4 5 6 7 1 2 3 4 5 6 plus max is 1 1 2. So max will become 4, answer will become 10. So I think it is always better to take them individually, right? Plus count of zeros. Yeah, individually plus count of zeros. Individually plus count of zeros, right? So individually j plus 1 minus I, I2 j plus 1, I will make, this is count of zeros, if ai is equal to 0, c plus plus, and then I will do answer plus equal to c plus j plus 1 minus I. 4, 13, 26, 53. Okay, that is still wrong. 13, 26. If I have 0, 1, 1, 0, if I have 0, 1, 1, 0, 1, why is it I'm getting 53, right? And 14 in that case should be the answer. I am getting 13. Two, 1, and 2, 0. 1 second. I have 2. I have 2, 0, 1. First, if I take only for 2, answer is 1. Then I take for 0, or maybe 2, comma 0. Yeah, for 2, 0 my answer is 3. For 2, 0, 1 my answer is 3 plus answer is 4. Then for 0 and 1 my answer is again 2. Oh sorry, 3. And for 1 my answer is 1. So the summation comes out to be, this is 10, 12. But I'm getting 13. Wait, why am I getting 12 here? 2. Okay, also like I can have a 0, separate 0. This will give me 2. So the answer should be 14, right? Yes. Why am I not getting 14 here? Is there something wrong in the code? Answer plus equals to C plus J plus 1 minus I. Are my loops going till N? Okay. Okay. Okay, let's do this. 0, 0. Okay, for the other one, 0, 0, 0, 1, 0, 2, 1, 1, 1, 2, 2, 2. Okay. Okay, and C plus J plus 1 minus I. Yeah. 1, 1, 2, 3, 2, 4, 1. 1, 2, 3, 2, 4, 1. How much was I getting? Answer is 1, 2, 0. 2 zeros answer is 3. 2, 0, 1 answer is 4. 2 plus 1, 3, right? Why am I getting 2 here for 0 and 1? K. My bad. Okay. That is a silly mistake. 4, 14, 26, 48. 4, 14, 26, 48. Yeah. Yeah. Okay. Problem C. Andrew has n piles with stones. The ith pile contains AI stones. He wants to make his table clean, so he decided to put every stone either in the first pile or in the nth pile. Fine. Andrew can perform the following operation any number of times. Choose 3 indices I, J, K such that the jth pile contains at least 2 stones. He takes 2 stones from the pile J and puts one pile into I and another pile into K. Fine. Tell Andrew what is the minimum number of operations needed to move all the piles. Okay. N 1 2 2 3 6. Problem C. Fine. Same kind of input. Okay. So we have this test case which will be used afterwards. Yeah. If I have 1 2 2 3 6, we have to put all the piles from here to there. We have to distribute it outwards. That means if I have 1 2, maybe let's get the example cases here. Also the input in this thing. Problem is little pretty straightforward. Or let's get the problem statement as well. Yeah, fine. So if we have something like this 1 2 2 3 and 6, we need to make it in such a way that all the middle in the middle areas we get 0 and we get some x and summation of a minus x. Here we have to distribute this array in such a form. Fine. So okay, what we can do is that if we have a b c, we can convert any a b c into a plus 1, b minus 2 and c plus 1 in such a way, right? Chooses 3 ijk such that the jth pile contains at least 2 stones. Then he makes 2 stones. Then he takes 2 stones from the pile j and puts one stone to pile I and k. Oh, yeah. So, okay, it is not actually this. I thought we have to take consecutively. We can take ai, aj and ak and move one from here to there. Okay. Okay, it will be always, first of all, it will be always beneficial to put to take directly, like directly, if it is possible, directly split it here and there. Okay, but then if someone is odd, if some of them is odd, then it might become a problem, right? So therefore what we could have done is that if I have 1 2 2 3 and 6, we can transfer this in one operation. 2 1, this will become 2 0 2 3 and 7. For this one also we could have done 3 0 0, and instead of putting that 1 into this 7, we can give it to this 3 4 7 and then 2 more operations. So in 4 operations we could have done the whole thing. Fine. Yeah. Okay, so what if, like, is it that if we have odds, like the total amount in the middle is odd, then I don't think there is any possible way to do it. Or even if it is even, if I have all the odds here, if I have all odds, then also -1. This can be done in one operation, this cannot be done because, yeah, all odds. This can be done in 4 operations. Fine. 1 second. Okay. But even if I have some like have odds, like 3 and 5, 1 and 1, I can do 1, 1. I can give 1 to this one, right? 6. Sorry. I can do 2, 1. I can do 6 and 1. Fine. Okay, so like I have some values here which is even. What I can do is like either I can redistribute everything inside this, or like maybe I give 1 this side and keep the rest here, or I keep 1 this side and keep the rest here, or I give in both the sides. Here I had some 8, then I gave 1 to the lasts, then I'm remaining with 7, right? I can also do this then. 2, 5 and 2. Then this 2 can be given to 3, 0, 6 and 2. Fine. And then finally what we can do is that 3 more operations. So I did 1 operation here, 2 operation here, 3 operation here. So in 6 operations I will be done with this. Fine. Okay, one of the thing is that. So basically what we did is that we took care of the odds. Fine. If my sum was already odd, I can take care of it in such a way that I can do 1, I can make this 2, I can make this 4, I can make this 2. Fine. And then it is done like normally. Fine. When will it not be possible? When if I have something like this, or maybe it is possible here also. Yeah. Okay, I can do it like this. 2, make this 2 and make this also 2 and 1. Fine. Then that is done because yeah. So if I just focus on the middle parts, that is if I have 5, 6, 3, something like that in middles, and outside I can have anything. Let's suppose 1 and 1. So in 5, 6, 3 what I can do is that okay, what if I had like 8, 0, 0? Sorry, I had 14, 0, 0, because the sum of these is also 14, and 14 is distributed in such a way, or 14 is directly. I can do it in 7 ways. Can I do this one also in 7? I'll have to see. 6, if I just had these and these two, I took 6 tries here. Okay, so the thing is that I have a net value inside, that is 14. If I'm distributing it among itself, it will take more times, because if I do a distribution step, it will do only -1. If I do a cancellation step, cancellation means giving both sides, then I do a -2. Or I can do a full distribution step, that is -0. I don't think a full distribution is required, or maybe it might be required, maybe it is beneficial as well, because I can do, if I have 5 6 3, I can do it like 4 and this 4 and this 6, and then it will take only 7 more steps. So it took me 8 steps to do that. Fine, it took me 8 steps to do that. However, I could have done it in such a way that I will 5 6 3 could have been done. This would have been become 3. That would have become 4 and 6 in one of the operations. Then some other operations, this could have become 4 4, and this would have become 4. Fine, and then this could have been done in 6 more steps. So the answer is 8 here also. Okay. Two, 2 2 6. Yeah. So the net sum, I had 14, that became to 13, that became to 12, and that 10 8, then 6, then 4, then 2, then 0. So 1 2 3 4 5 6 7 8 steps. Okay, total 8 steps it had taken me. It took total 8 steps, and here I had sum as 14, and then I converted that sum into nothing but 14 only. Okay, and then I could have gone, yeah. So it is always beneficial to like cancel all the odds first, right? In what order? Let's see. If I have 1 2 3 4 5 and 1 1 at the ends, that is okay. The summation is 10, right? In one operation I can do okay, I can make this 4 into 10. Ideally can be done in 5 steps, right? But to do 10 here in such a way, in such case, I can make it, this 2 can become 2 4 0 4 and 5. This 2 will become 0 0 4 4 6, and then it is like again 7 more steps. Sorry, it was 15, right? Yes, my bad. So I took 1 2 and 7, like 9 steps I took. So the sum went from 15 to 15 itself, and then to 15 to 14, and then 7 more steps, and then 7 more steps, right? The answer is always possible irrespective of the fact that irrespective of the fact that I have the sum as even or odd. But if I have all ones, then it is not possible. Even if I have like 2 1 2 I have, fine, this 2 can become 1 1 1 2 and 0, then that can initiate the chain reaction sort of thing. 0 0 2 1 1, this will become 1 2 0 0 0, this will become 2 0 0 0 0, and finally all zeros. So 1 2 3 4 5 operations, right? 1 2 3 4 5 6, sum was 6. Fine. Okay, and n is basically 10 power 5, right? N is 10 power 5, yeah, that is okay. Fine, actually. So if I had 1 1 1 and 3, I could have done 1 1 2 and 2. Fine. How did I do that? 3 1 and 1. Fine. Then I could have done 1 1 uh, 1 2 0 2, then 2 0 0 2, then 0 0 0 2, and then 0 0 0 0. How many operations did I take? 1 2 3 4 5 operations again, and summation was 6. Yes. So the number of odds, if I had this in middle, does the position of the things depend? If I have this like this, I can again make it 1 2 0 1 1, 2 0 0 1 1, then 0 0 0 2 1. Okay, then I can make this 0 0 0 0 2, and then 0 0 0 0 0. I again did that in 5 operations. That is okay, but will it never matter? The order. Will the order matter or not? That is my point now. So any number can give it to the outside values. And what am I doing is that I have some value, some other value, and some dumps here. I can at least do, either I do this, or I do this, or I do this. Yeah, these are the number of ways I do that. Or I can do internal distribution as well, but that is equivalent, I think. What if I had like 1 3 5 7? Fine. Then I can take the 7 6, then make this 5 3 1. Is it possible, like, I decrease down all of them? I can also do like this, right? Giving out 2s is okay. 1 second. Huh? Six. And what I could have done else is that take this 3, make this 1, make this 2, make this 6, take this 2 into 0, 2 and 6, and then 0 0 6, and then 0 0 4 0 0 2 0 0 0. 6 operations again. Yeah, it is equivalent. Yeah. So make this 2431, right? 2413. Just keep one odd as 3, rest all odds you can convert to zeros, right? And then finally what we get is that we will make this 1 2 and then we will make this 0 0 0 2 and then 0 0 0 0. Yeah, so basically this algorithm works. For now what I think that what will we do is that let us try to run that here once. Yes, so if I have 2 2 3 in the middles, what I can do is that I can make this fine. I got this 2 2 1, then I got this 0 2 1, then I got 0 0 2, and then I got 0 0 0. So those were the 4 steps here. If I have 1 3 1, it is negative 1. Okay, if I have a single odd value or all ones, yeah, then either single odd or all ones, then that is negative 1. If I have 1 2 1, I can just do it in one value. Fine, maybe whatever, only in one operation, fine. So basically what our algorithm will become at last will be wow. The image is not loading or what? There is some glitches in this OneNote app. I figured this out already many more times. Yeah, so basically what I'll do is that if I have like maybe some cases like 2 4 5 6 7 9, yeah, I can remove. Okay, I'll find one odd value. Let's suppose this odd will become 3, rest all will become zeros or ones, right? Odds, evens will become 0, odds will become 1. Fine. Okay, that one more thing I need to check once. Okay, having 1 3 0, or like if I have 2 4 5 9, if I have 2 4 5 3, I can convert it into 0 0, then 1 3. How many operations did I take? 1 2 3 4 5 operations already. Then what I can do more is that I can do 0 0 2 2, one operation and then 2 more operations. That took me around 8 operations. Yeah, that took me 8 operations. But if I have 2 4 5 3 and I leave 1 2 0 and 1 1, so this took 2 plus 2 4 plus 6 operations already. This will take me oh, this will take me more operations or what? Yes, because this will become 0 2 1, then 0 0 0 2, and then 0 0 0 0. This will take me 1 2 and 3. That is 9 operations, because of the fact that there I cancelled all the events already, so I have less number of terms remaining, and in one operation I can only generate one more new 0. Yeah, I can generate one more 0. Yeah, if I generate, yeah, once I have made the series of ones and threes and ones and twos, like that kind of series, it will always take me, or if I have like this, it will take me 1 1 okay, 1 2. Yes, it will take me this much amount of times. If I have 2 4 4 5 3, converting all to zeros, and this to 1 and that to 3, or leaving 1 2, converting all to ones, 4, same amount but from here. If I have 2 1 1 or I have 1 3, this will take me 0 2 1 0 0 2 0 0 0, and this will take me 2 2 0 2 and 0 0. I think it will take equal number of times. I miscalculated something here. This will take me 4, this will become oh, this will become 1, sorry. Okay, this will become 0 0 0 2. So how many operations did I take? 5 operations here, then 1 then 1 then 1. Still it is 8, right? Wait, I took 2 3 4 5. Okay, I took 5 operations here and it is 8. Fine, I understand. Okay, so basically the plan is that just take 2 okay, make all the events as 0. You have a bunch of odds. How many ever odds you have, convert them to ones. If I have only one odd, like suppose if I have 2 3 4 and 6, converting it in this manner is not a good idea, I guess. Or maybe I can do 1 there and then 2 here and 1 here, and then I can do again, and then I can make this like this. And then I can make this 0 2 and then 0. Yeah, so 1 2 3. In 3 operations I can cross a 3, right? But if I have 2 odds, then I have 3 and 1, let's suppose. Yeah, so I can do this 3 will become 1, this 1 will become 2, then 2 0 and then 0 0. So in 3 operations I can cancel a 1 also. But if I have 3 1 1, I can do 2, decrease it by 2. What? Decrease it by 1 2 1, then 2 0 1, then 0 0 2 0 0 0. How many operations did I take? 3 operations for this, and then separate operation, single operations for all these. For 3 and 1, it will become 1 2 2 0 and 0 0. Fine, and then single operations more. So if I have like 5 odds, fine, some of them should be like at least one of them should be greater than or equal to 3. Let's say I have 3 1 1 1 1. So these can be converted into 0 0, and this will be converted into 2 in 3 operations. How? 3 1, 1 operation, 2 operation, 3 operation. Fine. These 3 operations, and then single operation we can apply. This is 4th operation, 0 2 1. Then 5th operation is 0 2, and 6th operation. Fine. So 3 4 5 6. Yeah. So that is the answer, right? That is how we'll do it. Evens can be like directly made into zeros. So I have an answer. I will loop from 1 to n minus 1. If ai mod 2 equals to 0, I will do answer plus equals to, I will do answer plus equals to just that number ai divided by 2. Fine. And then I'll have an else condition. Else if it is an odd. Okay. We can count. Yeah, we can count if ai is greater than 1. Basically we'll do count plus plus. That means I have these many amount of, and I can also make a count odd, which is just the count of odds. These are the total number of total number of odds, out of which these are the odds which are greater than 1. Yeah. So minus 2. Yeah. If all odds are ones, this is also possible that I might have all odds as ones, right? I can have 2 4 6 8 and then 1 1 1 1 like that. So I will do this zeros. I will have 1 2, and I will have to do 1 2 3 4 5 6 more operations, right? If odd count, if odd count is there something, okay, that means I have some odd count and count is 0. That means I have to decrease answer minus 1 by 1, and then do answer plus equals to count of odd plus 1. That means, yeah, if I have 1 2 3 4 5 6, answer was 2, I decrease it again. Answer was 1, I decreased it, and then I added 1 2 3 4 5 6 0 2. Yeah. So answer will become 6. If odd count is there something, okay, what if like if answer is 0 already, that means like I had no evens. I had no evens at all. If I had no evens, all are odds, and count is 0, that means all are ones. So I'll just do minus 1. And also that if n equals to 3 and a of 1 is equals to a of n mod 2 is not equal to 0, then also I will just do cout minus 1 and return. Fine. Else I will always have an answer. Now what I will do is that I will just do this. Yeah, that is done. Now this was the case when odd count, I had some odds and I had some I had no odds greater than 3, all odds as ones. Fine. So in that case, if I have some even, I will do answer plus equals to the odd count. Now what I will have to do is that, let's suppose I had some odds. Fine. If I don't have any odds, then it is then the answer is directly very easy. If I have some odds and count is also there, fine. That means I have some number of odds which are greater than 3 as well. Okay. Yeah. So what I will do, actually, okay, let me just copy the loop again. Yeah, so I have this loop, right? Odds already done. Now if AI, yeah, AI mod 2 is not equal to 0, and so number is odd and AI is greater than 1, so I will do answer plus equals to AI minus 1 divided by 2. That means if it is 3, I want to convert it into 1, so 2 by 1, that is 1. Yeah, that is done. Now I have all the odds as 1s, all the evens as 0, but some odd had to be 3, so I'll do answer minus minus. That means one odd is 3, and now I have successfully made series all the evens as 0, all the odds as 1s, and one of the odd is 3, and also made sure that one of the odd is greater than, can be 3. Fine. So I have this 3 now. Now what I just need to do is that these will take 3 operations and these will take 1, 2, 3, 4 operations. 3 plus 4, like I have 1, 2, 3, 4, 5, 6, right? So odd count is 6. So my answer will become 3 plus 6 minus 2. So that will become 7, right? 1, 2, 3, 4, 5, 6, 7, yes. Yeah. Answer minus minus and answer plus equals to 3 plus count odd minus 2. That is basically 3 plus odd count minus 2, and minus 1 I already did, so minus 3. That is again equal to just odd count. Yeah, fine. Yeah, yep. So and then I'll just return the answer. Okay, odd count and count odd. I just messed up with that. It is count odd. Count odd, fine. 4 minus 1, 1 minus 1, fine. And if I have some, I'll put some other test cases, like if I have 5 values and in middle I'll put I have 1 1 1. How will it perform? Maybe I have only one odd. Four, 3 and 1, 4. Fine. If I have one odd and all others as evens, what will it do? 1. Okay, so 1, 2, 3, 4. 4 is correct. And what about this? 1, 2, 3, 4, 5. 5, right? Yeah. 1, then 2, then 3, then 4 and 5. Yeah, I think it is correct. What if I had zeros? Let's suppose it should give 0 because I'm not adding anything to the answer. Yeah. Yes. Let's try to submit this. Yes. That was C. 2160 rank currently. Fine. Okay. Fine, let's go and go for problem D. If it shows the expected rating change, I might wait for that. Okay, problem D is a mathematical problem. Okay, let's read the problem. You are given two arrays A and B, both of length n. You can perform the following operations any number of times, possibly 0 also. Select an index I, swap AI with BI. Let's define the cost of the array A as the summation of from I1 to n, from j I plus 1 to n. Your task is to minimize the total cost of the two arrays. Yeah, problem D. Yes. Problem D. Yeah. So let's analyze the cost at firstly. What does the cost want to say? What does it actually? What does the cost actually mean? Did the rating change appear? No. There are literally so many participants in this contest actually. Whatever. Okay, so we have a cost. That is basically summation of okay, it is the summation of I from 1 to n and summation of j from I plus 1 to n, and it is ai plus aj, basically ai plus aj whole square. Okay, that means if I have an array like 1 2 3, so the cost is 1 plus 2 whole squared plus 1 plus 3 whole squared plus 2 plus 3 whole squared. That means the cost will become 3 squared plus 4 squared plus 5 squared. That is basically 9 plus 16 plus 25, and that is 16 plus 9 is 25 itself, right? Yeah, and that is 50. Yeah, so what do we need to minimize? The total cost of the two arrays. Fine. Yeah, the total cost of the two arrays has to be minimized. How does any element contribute to the cost? I can always swap ai with bi, right? Plus bj. For example, if I had this 3 6 6 6 and 2 7 4 and 1, right? This means that I have, let's check for the explanation. If I swap these two in the second test case, in one of the optimal answers after all operations A. Okay. What I mean to say is that what I'm thinking currently is that if an element is at position J, it will be considered for, okay, if I have AI plus AJ, let's suppose I have AI plus AJ whole squared, this will become AI squared plus AJ squared, this is fixed, plus 2 AI AJ, this is the factor which has to be minimized. Fine. AI times AJ, so the thing is AI times AJ, which is basically what has to be minimized. Fine. For example, if I had this 6 and 4, right? So 366, right? My cursor, yeah. If I had, let's suppose I had like this, I had 366 and 274. So I'm just keeping count of this AI AJ, right? So for this index J, 36 is 18 plus 66 is 36 and 2 4s are 8 and 7 4s is 28. So the summation comes out to be 9 4s are 36, 9 2s 9 6 is 54. This is 54. This comes out to be 36 and both come out to be 90. But had I taken this 276, this would have become 12 plus 24, that is 36, and here I could have got 950, 9 6 is 54. I guess this is same, right? Basically, if I have some values x1, x2, x3 and y1, y2, y3, so the total cost, maybe let's prove this for two values itself. Okay, I have x1, x2, I have y1, y2, so the cost of this will become x1 square plus x2 square plus 2 x1 x2, and this cost is y1 square plus y2 square plus 2 y1 y2. And if I had x1 y2 and y1 x2, I could have got x1 square plus y2 square plus 2 x1 y2, and here I would have got y1 squared plus x2 squared plus 2 x2 y1, right? So the difference delta, if this is my difference, that is basically x1 x2 plus y1 y2 minus x1 y2 minus x2 y1. This is basically the difference which I am thinking, which I am getting. Fine. Maybe in this case my difference was 0. What is my difference? Okay, my difference was 9 6. Okay, the summation, what yeah, the summation of this and this, if you see, the summation of this and the summation of this is same. Fine, that is the reason why the cost was 0. Fine, because I can write this in this way, right? Okay, if I want to, I think, yeah, x1 y1 can be summations also, like sum of all the elements behind, right? So if I take x1 common, maybe I can get it like x2 minus y2 plus y1 as the summation, y2 minus x2. So it is x1 plus x1 x2 minus y2 minus y1 x2 minus y2. Okay, I can show it a little bit here. Yeah, that means what I can get is that delta is equals to x1 minus y1 times x2 minus y2. Fine. Yeah, and this x1 minus y1 x2 minus y2 is basically what? If x2 y2 is the index where I am swapping, so x1 will become summation, right? Summation of x till I minus 1 minus summation of y till I minus 1, and this will become xi minus yi. This will become the delta, the actual formula for delta. Fine. Yes, here the delta was 9 6 and 9 4, and if I swap 9 4 9 6, that is delta is 9 minus 9. Yeah, so the delta of that test case was 9 minus 9 times 6 minus 4. That comes out to be 0. That is why it was 0. Fine. So I need to maximize the delta, right? I need to, sorry, and that too, this is xi minus yi, right? And delta is what? Delta is the amount of, delta is how much better I'm getting, how much better answer am I getting. For example, if I have 6 7 2 4 6 7 2 4 and 2 5 3 5, okay, yeah, 6 7 2 4 and 2 5 3 5 5 3 5. Fine. So I can keep summation xi's, summation of yi, 6 13 6 13 15 and 19. This will become 2 7 10 and 15. Fine, these are my summations. So I can put delta. If I change it here, delta will become like, okay, delta will be 0. If I change it here, delta will become, let's calculate manually as well, and then check with the formula also, which will give you more intuition, whatever. Initially I had 42 plus 6 7 42 plus 10 minus, finally I got 30 minus 14, 30 plus 14, 30 plus 14, this is 52 minus 44, which is 8. That is delta. And with my formula also, if I calculate, I think I should get same delta, that is 4 into 2, yeah, that is 8. That is delta. Okay, yeah, so I just need to maximize, and wherever the delta is maximum, either I can swap here, or either I can swap here, either I can swap here, either I can swap here. So wherever I have the maximum delta, fine, maximum delta, there we can swap. And also it is okay, this was if only one swap was allowed, but I guess we have multiple swaps to be done. We have multiple swaps which are possible. So I think one more thing to be noted here is that if we swap, we don't affect deltas ahead. That means because, or do we? I think we do affect the deltas. Yeah, I think we do affect the deltas. That is why n is 100. Okay. Yeah, so n has been given as 100. That means, yeah, yes, we affect. But here we have the constraints for the rescue, but n is 100, right? So we can do order of n square something. That means we every time find delta, we every time perform this whole operation, finding the summation xi's and summation, and finding a delta which is like negative, which comes out to be negative, and wherever we get the first delta negative, wherever we get the delta as negative anywhere, we will just swap that. Okay. Yeah, and is there any order in which I will have to perform the swaps? Okay. If I have 264 and like 157, whatever, 3 and 5, something like this. So if swaps are needed here, so in any order, it doesn't matter if I approach the swaps in any order. That is what I feel. Even if I do this swap first and then that swap, or I do that swap and then this swap, the answer will be same or what? Or it is that if I approach from the right side, a swap which has been done in the right, fine. A swap which has been done in the right will not affect a swap in the left. Yeah, so I think I can do it from the right. Means if I swap something here, the array behind that doesn't even know if that swap has been done or not, because the answer here is just dependent on the prefix. So I can just can I do it in order of like linear time? For example, yeah, if I have 6 7 2 4 and 2 5 3 5, if I have this, the summation there is 15 xi minus yi, that is 5 times this minus 1. Swap is negative, delta is negative, so we don't need to swap here. Xi minus yi, that is 6 into minus 3, that is also negative, so we don't need a swap. Here it is 4 and 2, that is 8, that we require a swap. So our answer will become 6 5 2 4 and 2 5 3 5. Fine. And what will be our answer? Okay, 1 plus 16. I think I can do it on the calculator once. Okay, 1 plus 16 plus 4 plus 9 plus 1 plus 4 plus 9 plus 1 plus 9 plus 0 plus 4 plus 4. The answer is 62, but 62 is not. Okay, what do we need to print at the last? Minimum possible total cost, right? What is cost? Okay, for the above case, answer is 987, right? It is summation. Okay. My bad. Yeah, it is summation. Yeah, I did that wrong. Yeah, 121 plus 864. Okay, 121, 6 plus 2 8 64, then 10 100, then 49, then 81, and then 636, and then here 7 7 49, then 36, then 49, then 25, sorry, 100, then 100. Okay, then 64 and 64, 64, 100, 49, 81, 36, 49, 36, 49, 100, 64 and 64. We are getting 813. That is not correct. Let's just calculate the cost once. Okay, so 6524 6 6524 2535. $802. We needed to minimize, right? Yeah. Minimum possible total cost 6724. 1 second. What the 67 67 914, right? 914 is correct. Yeah, so I think we can do it in that way. The cost is also correct, answer is also correct, printing is correct, but we need to do some yeah, we need to first swap, right? So sum, prefix a int pa and 0 and prefix of b and which is 0. Fine, then I will start the loop, and this is basically bi, this is basically ai. Yeah, and we'll start it from 1, and pfi is equal to pfi minus 1 plus ai, and similarly for b. Yeah, and then we'll just start the delta, swapping the first position. Is swapping the first position also having any weightage? For example, if I have 2 5 and I have 3 3, the cost now is 49 plus 81, which is 130. But if I have 3 5 and 2 3, the cost now is okay, the cost now is 864 and 525. That is basically 9 and 89. That is 89, which is less than 130. So if I am having only one, x1 x2 y1 y2, so initial answer is x1 square plus x2 square plus 2 x1 x2 plus y1 square plus y2 square plus 2 y1 y2 minus new x1 y2 x2 y1, right? Minus x1 square x2 square, all these will cut. I will have minus 2 x1 y2 minus 2 x2 y1. Fine, so I will have x1 x2 plus y1 y2 minus x1 y2 minus x2 y1. Yeah, I think it is like when I made the formula, this one, what did I consider here? It is initially I had this one, then after swapping these two, I swap these two, right? After swapping these two, my delta became this thing, right? My delta became this thing, and if delta that is, I think this one is not correct. Yeah, this is not correct. For let us go and try for like 4 value, go for 3 values, right? x1 x2. Okay, let's go ABC and PQR. This is 2 Okay, let's leave 2 also. We have AB plus AC plus BC, and we have here PR PQ plus PR plus QR. Afterwards we have ABR, we have ABR, and we have P Q and C. So we get AR AB plus AR plus BR, and here we get PQ plus PC plus QC. Fine. So the delta here will become, here delta will become, these two get cancelled. We only have yeah, we have A plus B times C plus P plus Q times C minus A plus B times R minus P plus Q times R, yeah, times C. So basically what we get is that A plus B into C minus R, yeah, minus P plus Q into plus, basically plus, right, plus P plus Q into, okay, here we have P plus Q into C, that there we had P plus C into R minus C. So we got A plus B minus P plus Q, fine, into C minus R. That is the delta, which is basically the formula which I made earlier. Fine, this is the formula which I had made earlier also. Fine, yeah, so that is, I think, correct, because this is summation of AI, this is summation of BI, just the difference, minus 1 and AI times, this is just AI minus BI, yeah, that is the thing which comes out to be true. And if I'm just swapping the first element, if I swap any element, it will also change the further summations, right? It will also change the further summations. Okay, so we need to do the formula again, we need to do the thing again and again, we need to do it again and again, and we'll check it from the right. I guess that will work, yeah. And what to check, how to check the first element? If I just swap this A, B and PQ, so AB plus PQ minus PB minus AQ, because I exchanged these, fine, because I exchanged these, this will have an effect on the ahead values also. If I swap some values, the previous ones won't have, yeah, any, okay, yeah. So if I swap the first value, what will be the delta because of that? Actually the delta what I'm calculating is that when I'm just swapping the last value, if I swap the last value, then what delta am I expecting? Fine, yeah, it is the delta that I expect if I just swap the last value. fine, and not okay. Yeah, if I swap any value, if I swap the first value, okay, what is delta actually? Fine, let us go and think for a value which is in the middle. It is AB plus AC plus BC, again that is PQ plus PR plus QR, and if I had AQC, this is AQ plus AC, AQ plus AC plus QC, this is PB plus PR plus BR. Fine, what does cut? AC will cut, PR will cut, we will have, okay, we will have AB plus BC plus PR plus QR minus AQ minus QC plus QC plus PB plus BR. Fine, this is what is the overall delta. Now if we want to rearrange this delta, that means delta is equals to, okay, in the further run we know that A is some summation of the previous ones and C is the summation of the ahead ones. So A will become, yeah, so basically yeah, we will take B common out, we will take out B in common, right? So I get A plus C minus P minus R, and if I take Q out in common, I will get okay, PQ plus QR. This is I guess PQ, right? PQ, yeah. So I get, yeah, Q, P plus R minus A minus C, yeah. So this is basically B, A plus C minus P minus R minus Q, A plus C minus P minus R. So this comes out to be B minus Q into the A plus C, yeah, minus P plus R. This is the actual delta, yeah, this is the actual delta. I was a little confused about the delta concept. Actual delta is like, which can be concluded to be the following. It is like delta is just AI minus BI into the summation of AI. A plus C is what? Summation of elements excluding AI, and minus summation of BI minus BI. Summation of BI is minus that actual BI, fine. Yeah, So delta comes out to be ai minus bi, and we have summation of ai minus summation of bi we have minus ai minus bi, ai minus bi. Fine, this is the delta. Fine, this is the delta which we get again. Okay, so we need a prefix sum and a suffix sum also. Yeah, we need a prefix sum and a suffix sum. Is that okay? So what we need is a prefix sum and a suffix sum. Or no, actually we just need the summations, right? Why am I saying that like that? We just need summations, and summations will change according to, if I take something common, delta is again ai minus bi whole square. I will just take out summation of a minus summation of b upon ai minus bi minus 1. Yeah, this is positive, doesn't matter. What will matter is that we have summation of a minus summation of b upon ai minus bi, yeah, minus 1. This is the thing which will matter. Fine, it should be, delta should be greater than 0. If it is greater than 0, this should be greater than 1. If that is greater than 1, that means basically what should be the case is like summation of a minus summation of b should be greater than ai minus bi. Is this logic correct? That means, yeah, this is some constant value, right? Not a constant value, it will also change by doing the swap. Fine, if we do the swap, let's suppose I have 1 2 3 4 and I have 5 6 7 8. So summation, difference of summation is that difference of summation, that will become minus 4, and this will become, if I swap this summation is 10, this summation is 4 16 26, right? 11 18 26, yes. So this will become summation of a minus 16 yeah, that is positive. Delta should be negative, should be positive. Okay. 1 2 3 4. We just want the absolute sign, right? Or maybe let's find the delta in that way, in this way, ai minus bi minus 4 into summations into minus 16 minus ai minus bi 4. Fine. So that delta is positive, right? Minus 4 times minus 12 is 48. That is positive. That means I'll have a betterment of 48 in the answer, right? If I swap 1 and 5. Yeah. ai minus bi whole squared. Summation of ai minus bi is minus 16 upon ai minus bi is minus 4. That is minus 1. This is 4 actually. Oh, this is not correct because of the fact that cross multiplication of negative can make the sum this thing. So basically I just need to check this, or maybe yeah, we can check this, right? No need to put in division and all. We can check this. Yeah. In what order should we check? Can we just check any order? I think yes. We can check in any order. Once we swap, that position will not be useful again, right? Okay. Don't need prefixes in this order. I guess we will have to make another function. Perform swap. Array. It will take an array. Take the size. Or let's convert them into vectors. Fine. Yes. Vector of int and a b. Fine. Perform swap, and that is an integer. Maybe it will give me an int whether the swap is possible or not, right? Yes. Perform swap. Okay, int. It will tell me if swap was possible or not. It will give 1, otherwise it will give 0. Perform swap, right? That is done. Now I need to find the delta, right? Yeah, I have the summations now. Now for each place. At this position, delta is equals to, we just need to find ai minus bi, right? Ai minus bi, ai minus bi multiplied by summation a minus summation b minus ai minus bi minus b of I. Fine. That is the delta. This is the delta if delta is positive. That means it is beneficial to swap, right? So what I'll do is like swap ai with bi, and I'll return 1, and then I'll return 0 here. Fine. Yeah. Also, like, just for this thing, I can also keep a scene array. Scene. And then I do scene of I is equal to 1. If scene I, then just continue. Fine. That means I won't swap like again and again on the same place because of some weird reasons. Fine. And then I can just give a scene array also. Of 101 positions, all filled with 0. And I will give, I don't need prefixes anymore. I will just give, I'll just do a while one, int value is equals to perform swap a b with this scene. Fine. A b and scene. If val is equals to 0, then I'll break. Fine, I'll break, and that is it. Yeah, let us try to check. Uh, 0, 987, 914. Okay, that is coming out to be correct. If I have one. Okay, let's try to give some small answers. 2 3 1 1 2 3 2 3 4. $156. Let us also try to find the actual answer before this thing. What was the answer previously? 160 and then 156. Yeah. So the answer previously was 1011. Afterwards it became this thing. Fine. Let us try to submit this. Yeah. Fine. I don't expect it. Yeah, wrong answer on pretest 2. That was sure. But okay. Can I try to come from the last? We'll try to submit. I have no hopes from this also, but I'm just doing it like, okay. Yeah. I have half an hour more. It is a plus c, right? This can be written as a plus b plus c minus b. Yeah. Yes, that is the delta. If delta is positive, right? Okay, I can I do it in order of 1? Like, I just swap the maybe I won't do this. If delta is positive, what I'll do is that I'll swap this and SA will become BI minus AI minus AI, and SB will become AI minus BI, and then I swap both. And I don't want the scene. Yeah, I don't want the scene. I don't want this return. Okay, I want this to be wide. Yeah. Okay. Fine. These are just like partial guesses. I think these might work or these might not. Okay. Okay, so I think I would like to cover on the solutions for ABC first and then try D, so that I will like, this is just the tentative whatever I felt like in problem D. And if I end up solving that problem, then I might make a separate video for that, but I think now I will cover the solutions of ABC first. Fine, these will be some quick solutions. So solution for problem A. Yeah, let's go on the solutions. Solutions. Okay, so for problem A, it has we have been told that we have some array A. We have array A1, A2, A3 up till AN, right? We can break it into two parts and sort them separately. And at the last, what we need is that we don't want the fully array, the whole array to be sorted, right? Let's suppose I have an element A here, some elements, I have an element B here, then in the final array B is less than A. Fine, in the final array, if B is less than A, that means it is not sorted right now. The array is not sorted right now, and that means if the array is not sorted right now, that means I have some values A and B, right, which are in a situation like B is after A in the array but B is smaller than A. Fine, that is only the definition of not sorted, right? Not being sorted. So I can just break somewhere between A and B, and after the operation also A will remain behind B and it will remain as not sorted. So the answer will be yes. So the answer will be yes always. It will be no if I have no A and B such that A comes before B and B is smaller than A. Fine, therefore it is sorted. That means the array is sorted, and so the answer will become no. Fine, so my code was basically You just check if the array is sorted. The answer is no, else the answer is yes. Fine. Checking if the array is sorted is a very trivial task, and I'm not going to explain that. Fine. You can just go and do it by yourself. That is basically very easy. Let's go on problem B. Okay, problem B. Okay, let's go on problem B. Problem B. Yeah. In problem B, we have to find the summation of. Okay, I'm not going to explain the problem because it is a little tricky. What I did here, I'll tell that. Because of the very low constraints of the problem, which is basically n is equal to 100, because the constraints are so low, we can loop for each subsegment, right? We can loop for each subsegment. Now, for any subsegment, the thing is that breaking all elements individually is best. Fine. That means breaking each element individually is best, because we will have the maximum number of subsegments, right? Which is just the number of elements in the whole subsegment. And then wherever we have zeros, let's suppose if I have like 2 3 0 0 1 0 2 0 1. Fine, I have 1 2 3 4 5 6 7 8 9. So the answer for this will become 9 plus the max will become 0 0 0 0 0 for these, but 1 for these. Fine. So the answer will become 13, and I guarantee that the answer won't become in any other division. The answer won't be better, because let's suppose you just took these as single, but then you took this 3 as these 3 elements as a single subsegment. What will happen is that you will decrease the number of subsegments by 2, but you will always increase the max by 2, so that will cancel, and answer will always become 13. You can try it out for any case, and if you think, you can also get the logic why this works. But in any case, even if you try to increase the max, you will decrease the number of subsegments either by the amount you increased, or you will decrease it more. Fine. So the answer is so best is just to break it in all small subsegments, right, individually. So for each subsegment, just loop for each subsegment, and what we need to do for any subsegment, just answer is length of subsegment plus count of zeros in it. Fine. Just loop for all subsegments, and then iteratively count this as well. You can do this in order of n cube, or use prefix sum to do it in order of n square. Using prefix, you can do it in order of prefix count, like count of zeros you have already kept. Fine. So that was B. If I show you my code in B, if you want to see my code, like, it is a very easy task after this, but even if you want to see the code somehow, you can see the code here. I just loop here. Yeah, I'm just doing a loop, a double loop, and then this is a count of zeros. If AK is 0, then I just count plus plus. Then answer is like, this is the length, j plus 1 minus I is the length, and C is the number of counts, number of zeros. And for each subsegment I just add and then return the answer finally, right? So that was problem B. Problem C. Problem C here. Fine. So problem C. Yeah. Problem C is a very good problem actually. It is not that difficult to think about, but okay. Let us do problem C. Yeah. In this problem, we need to take care of, I again assume that you might have read the problem statement already. Okay, because even if you have not and I explain you the problem statement, it is no use to see the solution, right? So I have some value here and some values here and some value at the last. Basically I have an array. I need to make all of these zeros eventually, right? And in any task, if I take AI, AI, AJ, AK, I have to transfer one to this and one to this. That is the allowed operation which I am given, and I have to minimize the number of operations to get all zeros. Fine. So even first of the yeah, firstly you can observe is that if you have all evens like 2, 4, 6, 2, 8, 2, 6, something like this, okay, it is like always optimal to just transfer in bunch of 2s to the ends. Fine, like that, and make all of them zeros separately. But if you don't have something as even, then what you can do is that, like, let's suppose you have this here, also you had this boundary. Fine, let's suppose you had 2 and 3. What you could have done, what you could have done is that give one to the left bound, but give one in the right to this 3. You could have converted this into 0, 4 and like that. Fine. Okay, yes. So I would like directly come on the actual solution. How will we do this? So basically what we could have done is that, so by seeing here we can also always see that reduce all evens to 0 directly. Fine, reduce all evens to 0 once, and count its answer. Fine, now we are remaining with all the odds. Fine, now in this we might have some cases like we have all the odds like this, all the odds as ones. Fine, then the answer is -1, because if I have all the odds as ones, and also the fact that I have no one of the cases like I have no evens and all odds as ones, so I have an answer of -1. Fine. Otherwise what I could do is that I can just when I reduced all the evens to 0, right, so I will have some zeros in the array and rest all as ones. So I can just increase again, I can just redo undo one of the operations which I just did on the evens. Basically I want to say that I can just choose one even and stop it till 2 and not take all the evens to 0. And then what I can do is like, if I have a 2 and a 1, I can just do like this, and I can convert this into 2 and a 0. Fine. So if I have a series like I have a 2 and rest all ones, so the count of all the values which are not 0, like 1, 2, 3, 4, 5, 6, 7, 8, that is the answer for this case, because in each operation I can just make one of the 2's to 0 and other one into 2. In this operation that will get cut and this will become 2, then this will get cut, this will become 2. So in 8 operations I will finish this whole. Okay, fine. Now let's suppose I had all sum of the odd, like one of the odd number as greater than 1. So I reduced all the evens to zeros. I have some zeros. Fine, I have some ones, but I have some odd which is some odd I had which was greater than 1 also, that was 3. Like, or maybe let's suppose we had some zeros in the starting which was let's focus on only the odds. I had odds like this 1, 5, 3, 7, 5, 3, okay, or maybe 9. Yeah, so these were the odds. Now we have to solve for the odds, right? Okay, so basically what is better is that how much ever it is possible to reduce, we can greedily do that, because that means We can reduce 4 out of this to make this 1. We can reduce 2 out of this to make this 1. We can reduce 6 out of this to make this 1. And we can reduce this to 1. And we can reduce this to 1. But again, if we have all ones, then it is not possible, right? So we can just stop one of the odds to 3 and others to 1. And then what happens is that you can do this like this. You can convert this series into a series of 1s and 2s. 1s and a 2, like so. You have 1 and a 2. When you give 1 to this one and 1 to this one, fine. And then your answer will become just the count of all odds plus 1 from here. That means, or maybe once you do this, you have already done some operations, OP one amount of operations, then you did one more operation, and then your answer will become 6. That means 1, 2, 3, 4, 5, 6 for all this. Okay, so that was basically C. Yeah, some of the corner cases were this one. Yeah, one more corner case is like if you have only a single value in this place, and that is an odd value. Okay, A0, A2, and one odd value. In this case also, you have an answer of -1. Fine. -1. 2 cases have -1. All these are the other cases, right? If you see my code in C, I can explain you that as well. Fine. Yeah. So this is C. This is the corner case when n is equals to 3 and the middle element is odd. Now what I do is that I just loop from 1 to n-1, 1 to n-2 basically. All the odds I will reduce to yeah, maybe let me explain it here. Yeah, come on. Yes. So here what I was doing is that this is the corner case when n equal to 3. Okay, here what I do is that reduce all evens to 0 and just count all odds and all odds greater than 1. Fine, greater than 1. That means here if I have some odd, this means this condition is all odds are 1s only. Fine, I don't have any odd which is greater than 1. Fine. This condition actually, because if answer was already 0, then I had no evens previously and all odds are also 1s. Fine. Else what I will do, I have some even, right? So I will just do the I will just add the count odd, because I'll explain you why I'm doing this. Also, if I have count odd and count, that means if I have some odds and some odds are also greater than 1. Fine. So I will just reduce all the odds to 1s and then I'll do this. Why doing this will work in both cases. That means if I have all the odds like this, fine. So I have some answer, right? So what I can do is that I can just roll back one of the ones to 3. So I will have answer -1. Fine. Now in this case, I can do 1, 1, 1, 1, 2, and 1. That is answer -1 plus 1, and then the count of odds plus the count of odds. So this will cancel, and I will get answer plus equals to count of odds. Fine. And here we had some we had some odds, like we converted some evens to 0 and all the rest odds are 1, right? So we had some answer over here. Now we can roll back. We can convert, we can just undo one of the evens to 2. Fine. So answer will become answer -1. Yeah. And then answer will become, and then for these, it is count of odds plus 1, right? Yeah, that is answer -1 plus count of odds plus 1. So 1 1 1 will cancel, again answer will become answer plus count of odds. Fine. So that was basically the solutions of the contest. Fine. Of ABC. Problem D, I could not do it till now, so there's no point in explaining what I'm doing. If you want to see what I was tentatively doing, you can see the ending part of my solving area when I was solving the problem. That time you can see, okay? And basically what I think is that I might increase the rating. I might get an increase in the rating because of the fact that this is a global round and there are too many participants of higher rated. I don't know actually, but whatever, like I think the cat survived this contest, and these were the solutions of ABC, and bye bye.